Okay, so this is probably the most important video that you're going to watch for the entire unit. This is going to give you the basis of how to do reaction stoichiometry. All right. Uh, Let me give you an idea of what we're focusing on here. The whole idea is that if I have, let's say I've got 5 grams of what's a reaction we want to do. Let's say I've got, what's one that y'all have done? Okay, you remember when we did the copper carbonate lab? And we started off with a mount of copper carbonate, and then we decomposed it. It was the one that was green, and then it turned to black, and then it made the carbon dioxide gas. Okay, and we had a mass change there. So the idea behind reaction stoichiometry is saying, okay, if I start off with 4 grams of copper carbonate, how many grams of copper oxide am I going to form, and how many grams of copper or of carbon dioxide did I form, or how many liters of carbon dioxide did I form? Okay, there's very specific amounts. If I am going to do a reaction between, let's say, hydrochloric acid and sodium hydroxide. Okay, and I take just a little bit of hydrochloric acid and drop it into the sodium hydroxide. I'm not going to form this crazy amount of NaCl. Okay, it's just going to be just the amount that it's all based on how much I have. Okay, so the first kind of problem that we need to look at is called a mole to mole problem. All right, this is where I had told y'all last unit that 1 always goes in front of the mole. Okay, and that's true for unit 9. Okay, but now we're going to add in a mole to mole situation where I'm going to say, well, let's just do a problem. Okay, it says use the balance equation for the synthesis of water and determine how many moles of water would form if you began with 32.38 moles of oxygen gas. Okay, so the first thing we have to do every single time, we have to write our balanced reaction. Okay, so I'm going to write 2H2 plus O2 yields 2H2O. Okay, that's on the previous page if you need to take a look. Okay, nonetheless, this is my balanced reaction. So the next step every single time is you're going to take your given. So I've got 32.38 moles. Okay, I'm going to write the given amount underneath whatever unit or whatever element or compound I'm dealing with, whatever reactant or product I'm dealing with. So in this case, I'm dealing with oxygen gas, so I'm going to write 32.38 moles directly underneath oxygen. Okay? It asks me how many moles of water, okay, how many moles of water would I expect to form? Okay, so what I'm going to do is I'm going to go to water. I know that I'm looking for moles, and it's an unknown amount of moles. So I'm going to do question mark moles. Okay, now if you are in a reaction, okay, the only way you can get from one reactant to the other reactant, or one reactant to a product, or a product to another product, the only way that you can relate those two things is via a mole ratio. Okay, so this mole ratio right now, if I have 2 moles of hydrogen, that would react with 1 mole of oxygen to form 2 moles of water. So my ratio then is 2 to 1 to 2. Okay, so my ratio of just oxygen to H2O is a 1 to 2 ratio. Now a lot of y'all can probably already see what the answer is going to be. However, I want to go ahead and start this problem the way we're going to start all the other ones because you need to see where we're going to start and how to start all these problems. So I can go from moles to moles. Okay, that's not a problem. I can go from moles of this to moles of that. So what I'm going to do is I'm going to make a T-chart. I'm going to start my T-chart off with 32.38 moles of O2. You remember in the last unit when I said don't get lazy on your units? This unit, you absolutely cannot get lazy on your units, okay? You have to say moles of O2, not just moles, okay? Do not get lazy. So now I'm going to bring moles of O2 down, and I'm going to go to moles of H2O, okay? What numbers go with moles of O2 and moles of H2O? Oh, the 1 always goes with the moles, except now, okay? Now, anytime and every time and anytime that you have moles over moles, okay? If you have moles over moles, you have to use the coefficient of whatever that compound is. Okay, so for H2O, my coefficient is what? 2. So I'm going to plug a 2 in. My coefficient of oxygen is 1, or assumed to be 1, because there's not anything there, so it's assumed to be 1. So I'm going to put a 1 in right here. Okay, now all I'm going to do is I'm going to do my math. Okay, 32.38 times 2 divided by 1 is 64.76 moles of H2O. And that, my friends, is how it's done. Now, once again, that's a pretty easy, pretty simple problem. And yes, we are absolutely going to trick it up from there. Okay. This says we're going to be dealing mass to mass and particles to mass. Remember, let's just do a problem. Let's just do a problem. Write down mole ratio. That's going to be our bridge to get from one thing to another. Okay. But let's just do a problem. Okay. I'm so excited about this, and I think y'all are too. So we just need to do a problem. Okay. This says how many grams of sodium chloride could theoretically be formed? If sodium chloride is being formed, we know that it's a reactant or a product. That's correct. It's a product. Okay. So I'm going to write NaCl on the product side. Okay. It's a synthesis reaction, and we start off with 30 grams of chlorine gas and excess solid sodium. Now we're going to learn to love this word excess. Okay. You're going to learn to love it, but right now it doesn't mean a lot to you, so we'll deal with loving it later, okay? So I know that I've got sodium, all the sodium in the world, okay? I've got more sodium than I know what to do with, plus chlorine gas, and that's going to give me sodium chloride, okay? So this was a solid, chlorine gas, and this is a solid as well, okay? So now, what do I need to do? Can I just start? No, I've got to balance this bad boy, okay? So I've got 1 sodium, 1 sodium. That's good. 2 chlorines, 1 chlorine. That's not good. So I need a 2 here and a 2 here, and everybody's happy, okay? So now our next step is to determine what our given is, okay? Our given is 30 grams of chlorine gas. So what I need to do is I need to write 30 grams directly beneath chlorine gas, okay? I want to know how many grams of sodium chloride I can form, okay? So I'm going to go question mark grams for sodium chloride. This is the biggest part of the video. This is the biggest part of the unit right here. We're getting ready to do the key step, okay? We're going to do something called the mole road, okay? And on the mole road, what we have to do is, remember, the bridge to get from chlorine to sodium, okay? The bridge to get from chlorine to sodium is, sodium chloride is through moles, okay? So what I need to do is I need to convert 30 grams to moles. So watch what I'm going to do. I'm going to go on the mole road by going from grams. I'm going to draw a little arrow, and I'm going to go to moles, okay? Now this is grams of chlorine. I know that because it's underneath chlorine. This is moles of chlorine. I know that because it's underneath chlorine, okay? Now that I've gotten to moles, what I can do is I can go from moles of this, and I'm going to shoot over my mole road to get to moles of NaCl, okay? So now I'm at moles of sodium chloride. Now I can deal with that realm of this problem, okay? The question now becomes, can I go from moles to grams of NaCl? Of course I can, because I can know the molar mass of sodium chloride, not a problem, okay? So I go from moles to grams, okay? Here's the wonderful part. Are you ready for this? This is going to blow your mind into a million pieces, okay? Here's the wonderful part. The mole road map that we made, okay, we made ourselves a little map there. This mole road map tells us exactly how to set up our T-chart. Does that not blow your mind into 1,000 pieces? Mine is destroyed now. I don't even know what to do, okay? 30 grams. Watch this. You're going to love this. 30 grams, 30.0 grams of Cl2, okay? Oh, what do I do now? Okay, so what I'm going to do is I've dealt with 30 grams of Cl2. Now I'm going to go to moles of Cl2. Oh my gosh, it just fits. It all fits right in there. Boom, I did that. Now, where's my next step on my mole road? Moles of Cl2 to moles of NaCl. Boom, put it in there. Where do I go next? From moles of NaCl to grams of NaCl. Boom, put it in there. It fits perfectly. This is unbelievable. Okay. Now I know I've got to slide everything down. So I've got grams of Cl2 here. I got to put grams of Cl2 here. Moles of Cl2 here. I got to put moles of Cl2 there. Moles of NaCl, moles of NaCl. Now all I have to do is fill in the numbers based on the relationships that I've already learned in the last unit and a little bit in this unit, okay? So for this, all I've got to do is I'm going to put a 1 with my moles, and then I'm going to put the molar mass with grams, okay? So Cl is 35.45 times 2 is 70.90, okay? Moles over moles, what do? I go back to my problem and I look at my coefficients, okay? What's the coefficient for Cl2? 1. So I put a 1 in for my moles of Cl2. There it is, 1, okay? What's my moles of NaCl? 2. So I put a 2 in for moles of NaCl, okay? Now I'm to moles of NaCl compared to grams of NaCl. So what do? This one, the 1 does go with the mole, okay? The molar mass is going to go with grams of NaCl. Molar mass being of sodium is 22.99 plus chlorine is 35.45, and I get 58.44. Where's my pen at? There it is. 58.44. Okay? And so now I just do my math. Okay? And so we get 30. Oop, not 300. 30 times 2 times 58.44. Enter. Divided by 70.90. Enter. 49.45557,123. Okay, now obviously that's way too many sig figs. I need 4 sig figs because that's what my problem has. 4 sig figs, so I'm going to do 49.46. And my last unit here is grams of NaCl. Boom. That just happened right there. And so now I know, let me explain to you what we just figured out here. Now I know that if I start off with 30 grams of Cl2, I can form exactly 49.46 grams of NaCl. Okay? Now that's in theory. Okay? That's theoretically. If everything in the reaction goes perfectly, there's no side reaction, so on and so forth. We can't guarantee that there's not going to be a side reaction. All we're worried about right now is the theoretical yield. This, my friends, is the theoretical yield. Theoretically, if I start off with 30 grams of Cl2, I can theoretically make exactly 49.46 grams of NaCl, assuming that I have all of the sodium that I'll ever need. Okay? We're going to do so many problems that you're going to fall in love with reaction stoichiometry right here around Valentine's Day. I feel like it's appropriate. All right. You folks just get ready for the next video and have a wonderful day.